You're at the edge. Not the edge of a continent, not the edge of the solar system, not even the edge of the Milky Way. You're at the edge of everything. Behind you, 100 billion galaxies, every star that's ever burned, every planet that's ever turned, every life that's ever drawn a single breath. The entire observable universe, all 93 billion light-years of it, packed behind you like a world you're leaving forever. And in front of you? Nothing. Or at least, that's what we thought. Because what actually exists beyond the boundary of our universe isn't nothing. It's something far stranger, something the human brain was never built to handle. And once you really hear it, really sit with it, the universe you thought you lived in is never going to feel the same again. Here's something most people don't realize. When astronomers say the observable universe, they're not describing the whole universe. They're describing the part we can see, the fraction of existence close enough for light to have reached us in the 13.8 billion years since everything began. But the universe didn't start small and stay small. From the moment of the Big Bang, space itself expanded. And not into something else, not into some pre-existing void it was filling up. Space is the something. It's the stage. And here's the thing about the stage. It doesn't have a speed limit, which means it expanded faster than light. And that sounds impossible until you realize that rule only applies to objects, and space isn't an object. This means there are regions of space that existed at the Big Bang, regions that were once right next to us, that have now been carried so far away that their light will never reach us. Not because they're gone, because the space between us and them is expanding faster than light can cross it. They're out there right now. We will never see them. And that's just the beginning of what nobody tells you. The observable universe is roughly 93 billion light-years across, but physicists estimate the entire universe. The real one, the full one, the one we can't see, may be at least 250 times larger than what we observe. Some models push that multiplier into the millions. Some models say it's infinite. Infinite, not very, very large. Infinite. A universe with no edge, no center, no end. A universe where, if you traveled far enough in any direction, you'd eventually find another region identical to ours. Same galaxies, same stars, same Earth, same you, making the same choices, reading these same words right now. That's not science fiction. That's one of the leading models in modern cosmology. And it gets worse. Think of the observable universe as a bubble. You're at the center. Light from the edges of that bubble has taken 13.8 billion years to reach you. Beyond the bubble's edge, beyond what's called the cosmological horizon, the expansion of space has outpaced light so completely that whatever's out there might as well not exist for us. But it does exist. The question is, what is it doing out there? Current physics says the universe beyond the horizon follows the same rules as ours. Same speed of light, same laws of thermodynamics, same gravitational constants. We've got no evidence suggesting otherwise, and for a while that was kind of reassuring. Here's what nobody tells you. There's a scenario, mathematically consistent, supported by several inflation models, called bubble nucleation. And the idea is this: our universe isn't alone. It's a bubble, one of an unknowable number of bubbles that formed during a period called eternal inflation, a runaway expansion of space that never fully stopped and may still be happening right now, churning out new universes the way a boiling pot generates new bubbles. Each bubble, a separate universe, each one potentially running on different physical laws, different constants, different rules, and those bubbles can collide. Ours may already have been hit. In 2010, cosmologists Roger Penrose and Vahe Gurzadyan published a paper claiming they'd found something strange in the cosmic microwave background. The oldest light in the universe, a faint afterglow still detectable from the Big Bang itself. They found concentric rings, circles within circles, too geometrically perfect to be random noise, showing up in regions of the sky where temperature fluctuations behave differently from everything around them. Their interpretation? Echoes. Gravitational shock waves from before our universe existed, from a previous cosmic cycle, or from a collision with another universe entirely. The scientific community didn't just accept it, they pushed back hard. Some researchers couldn't replicate the findings. Others came back with new patterns that complicated things further, and the whole debate turned into exactly the kind of slow-burning scientific argument that doesn't make headlines but absolutely should. The debate isn't closed. But here's where it gets crazy. If those rings are real, if they're genuine artifacts of a collision between our universe and another, then whatever's beyond our horizon isn't just sitting there. It's active, it's expanding, it has structure, and at some point, it may make contact again. Not in a way you'd survive, not in a way anything would survive. Let's put you there. Stick with me here. Imagine you've been dropped at the cosmological horizon, the actual boundary of the observable universe. You turn back. Behind you, the cosmic web stretches in every direction, faint and thread-like, luminous filaments of galaxy clusters separated by voids so enormous that if our entire solar system were a grain of sand, those voids would be the Sahara, every single one of them. You turn forward, your instruments read nothing, no photons incoming, no cosmic microwave background radiation from this direction, no hydrogen emission, no signal of any kind, but space is still there. You're still in it. And then your body starts doing something weird. Not because the physics changed, because of what the isolation does to your mind before your instruments even get a chance to fail. At this distance, the Milky Way isn't visible. There's no reference point, no up, no down, no sense of motion at all. Your vestibular system, the biological hardware that tells you where you are in space, starts reporting signals that flatly contradict each other. And then your instruments catch something, a faint, diffuse background, not light, not heat, but a statistical pattern in the distribution of quantum fluctuations around you. A pattern that shouldn't be random. A pattern that looks almost impossibly like structure. You're not at the edge of nothing. You're at the edge of something that doesn't have a name yet. Here's the thing nobody tells you about the multiverse. It's not something physicists invented to patch holes in their theories. It's a prediction, an unavoidable mathematical consequence of two of the most well-tested frameworks in all of physics, quantum mechanics and cosmic inflation. Inflation theory, which describes that explosive expansion of space in the first fractions of a second after the Big Bang, predicts that inflation didn't stop uniformly everywhere. In some regions, it ended, settled down, and formed universes like ours. In other regions, it kept going, and it's still going today, constantly spawning new bubble universes, the way a pot of water that never stops boiling, never stops making bubbles. This is called eternal inflation. And according to this model, the question isn't whether other universes exist. The question is how many and what's actually inside them. Some of those universes may be running on slightly different physical constants, a universe where gravity is just a little stronger. Stars collapse too fast, no time for planets to form, no time for life to get a foothold. A universe where the electromagnetic force is just a little weaker. Atoms don't hold together, chemistry doesn't exist, and neither does anything made of it. Wait, because here's where the really terrifying part lives. We exist in a universe that's been tuned, almost absurdly precisely, for complexity, for chemistry, for biology, for consciousness. And the question that's been keeping physicists up at night isn't whether that tuning happened, it's why. Was it inevitable? Was it designed? Or were there simply so many universes rolled out by eternal inflation that, by pure statistical weight, some of them had to land in that narrow range where existence is even possible? And we find ourselves in one of them for the same reason you always find your keys in the last place you look? This is the anthropic principle. And honestly, it's kept physicists awake far longer than any ghost story ever could. There's one more thing. Even within our universe, the one we can see, the boundary isn't fixed. It's moving, retreating. Because the expansion of space isn't just continuing, it's accelerating, which means every year, more of the universe slips past the cosmological horizon and becomes permanently invisible to us. Right now, roughly 100,000 galaxies per year are crossing that line. Right now. While you're watching this, hundreds of thousands of stars are making their final crossing into permanent invisibility. Their light is still in transit. It'll arrive here in billions of years, and then it'll stop. And those galaxies will simply cease to exist for any observer inside our universe, the way a ship disappears over the horizon, except there's no getting on a plane and flying over to check. In roughly 2 trillion years, a number so large it genuinely has no human equivalent, nearly every galaxy visible in tonight's night sky will have crossed that line. Future civilizations, if any exist, will look up and see only our local group. A handful of gravitationally bound galaxies floating alone. They'll have no evidence the rest ever existed. They may conclude the universe is small, local, empty. They'll be wrong, and they'll have absolutely no way to know it. Here's the final piece, the one that actually changes everything. If eternal inflation is correct, if the multiverse is real, then our universe isn't just one of many, it's one of infinitely many. And here's what people miss when they hear that word. Infinity isn't a large number. Infinity is a completely different category of thing. You can't count to it. You can't visualize it. It doesn't play by the same rules as big numbers do. In an infinite multiverse, every possible universe that can exist does exist, including universes where the laws of physics allow for faster than light travel, including universes where the Big Bang produced structures so different that life took forms we don't have words for, including universes with more dimensions of time. And here, right here, is the thought that scientists don't really like to say out loud. If the multiverse is infinite, and if all possibilities are realized, then somewhere out there is a universe exactly like ours. Identical. Same history, same planet, same civilization, with one difference. In that universe, the beings who developed physics looked at their equations, the same equations our physicists work with every day, and they found a way through, a way past the cosmological horizon, a way into the space between universes. We don't know if they made it. We don't know what they found. We have no way to ask. But the mathematics doesn't forbid them from trying. And it doesn't forbid us from trying either. Every time you look up at the night sky, you're looking at a fraction, a thumbnail, a single torn page from a library that has no walls and no ceiling and no end. The universe you can see isn't the universe that exists. What lies beyond the horizon isn't absence. It's everything we haven't named yet. Everything physics predicts but can't reach. Everything that, by the cold logic of infinity, must exist somewhere out there in the dark between the bubbles. We're not at the center of the universe. We're not even at the center of our universe. We're one signal in one bubble, looking outward, and just barely beginning, to understand how large the silence really is. And that silence isn't empty. It's full of everything. We just don't have the instruments to hear it yet. If that left you unsettled, good. Subscribe. Because what we're covering next is going to make this feel like the simple part. What exists beyond the universe? The answer will unsettle you. The observable universe spans 93 billion light years. But that's not the whole universe, not even close. Beyond the edge of everything we can